project is on object detection using OpenCV and YOLO Volume 3. So, so we are implementing YOLO and COCO labels to actually perform this project. The reason is in daily life, let's say we have to do, for example, a survey on counting number of vehicles on the road or anything. It is extremely difficult to do it using manpower. Over here, we can set up different surveillance cameras in traffic lights and utilize that to count the cars and use this project. So you can see, okay. So over here, YOLO is a network architecture which will take live video feed and make a grid on it and then recognize whether there are different objects present and what type of objects are present. And COCO is actually the different types of labels like car, bicycle, pedestrian, like so. The same thing that it's very difficult to for humans to recognize and count all the vehicles and count you know, crowd control, etc. But we can take the help of surveillance and do it digitally. So for this, we are going to require uh, TensorFlow, YOLO, a regular laptop. So TensorFlow, what TensorFlow will do is that it will create a blob, which is it's going to take an image, it will standardize the image, and after standardizing the image, basically the standardization will happen by resizing the image by and adjusting the contrast, the lighting, etc., the brightness, etc., and making the image perfect for the algorithm to perform more accurately. And YOLO framework is going to basically make the grid on the image and detect the objects present in the live video feed. Okay, and then there is a Visual Studio Code which we will use to run the pre-processing. It's the same thing, how to create a blog. So for a blog, we will take an image and a standardized image. We have set it also. It resizes the image size to 448 into 448 and also normalizes the contrast and brightness effects. The image is also cropped and resized so that the feature extraction can be performed easily. The input images are pre-processed and very easily normalize the contrast and brightness. Okay, now I will explain how the framework is working to recognize the objects. So the YOLO framework, okay, so the YOLO framework, what happens is that, let's say there is a camera that is reading all the images around, okay. So it will first form a grid over it. And then after forming a grid, it will see in which boxes there might be an object. You can see that they have given a formula over here, S into S into B into 5 plus C. So over here, the S into S is the size of the grid. Okay. What is the B? B is the boundary, what is it called? Is the boundary boxes. Okay. So boundary boxes are the boxes where an object is most probably there. And C is the classification, the class probabilities. The class probabilities are, let's say, like I had already explained, that COCO will provide labels. So pedestrians, cars, vehicles, different types of things are there. So what the C over here will determine is that, let's say if there is a car, then the C value for it will be uh, 0 for you, because in the image you can see that there is a bicycle. So for that it will show 0. But let's say the C value for a bicycle, it will show 1. So that's about it. Now this is the use case diagram. First, an image will be uploaded, multiple images will be uploaded from the video feed, and then it will get taken initialized by the system, and then a grid will be formed by YOLO over the images that are taken from the live video feed, and then and where the images are present, that will be determined. Classification and localization will happen, and finally, when the object is decided, okay, this object is present, this car is present, this pedestrian is present, it will reach to recognition state, and then a general output will be provided. This is the activity diagram of the same thing. You can see it over here. Then there is a sequence diagram of the, again, same thing. This is the architecture of the system, and input of the image will happen, then processing will happen, classification and localization will happen, and output will be provided. So this is how the first libraries will be incorporated. The CV2 libraries will be incorporated, and NumPy will be incorporated. NumPy will deal with the added manipulation, and then we will load the YOLO. So over here, the YOLO configuration will deal with the network architecture, and YOLO weight will basically decide that what kind of objects are present. And then you can see that layer names is there. So over here, different types of layers will be recognized. Let's say, okay, different types of layers will be recognized. In the layers, what will happen is yeah. What is it doing? Okay, layers, it determines like different types of objects that are present. Let's say what's in the focus, what's in the background, whether the particular section of the image that we are dealing with is a part of the object. Is it connected to another object, etc., etc. So you can see over here, it will determine different types of layers. It will give names to it, and also determine whether they are interconnected. Then loading the image, yeah, so the image will be loaded, and then a blob will be formed. So the blob will be a 4D input, and it will have the height of the object, the width of the object, and the size of it, etc. And once that blob is passed and it is determined, then this line out equals to net dot forward. This will provide the result of whether this object is a pedestrian or a car or whatever. So this is an example of the detection. And now I'm going to explain this thing. So you can see that on the left hand side, we have given you the Y values. Okay. So now we're going to move to the right side. You can see there are two images. One image has a car in it, another image does not have a car in it. So the image that has a car, you can see that the first value given is 1, then there is Bx, then there is By, then there is Bh, then there is Bw, then there is 0, then there is 1, then 0. Okay, so the first one value is showing that there is an object present in the image. There is a car present in the image. Then Bx is the x coordinate of the image of the car. Then there is By, which is the y coordinate, and then Bh is the height, and Bw is the width. Then 0, 1, 0 is the class probability. So okay, so C1 is the probability for a pedestrian, C2 is the probability for a car, and C3 is the probability for a motorcycle. So you can see that there is a car, so say they are showing 0, 1, 0. That's it. Then again, then there are multiple objects and how they will be determined. You can see that. That's